Hey guys, I'm Justin Woodring. In just over 6 minutes, I'm going to give you a crash course in everything you need to know and everything I wish I knew about memory addressing and pointers in C. Let's get started. Okay, so we're going to try to give a little bit of meaning to variables and pointers before we move ahead. And most people here are probably familiar with the concept of what a variable is. That is a location, or it is basically represents a name and a location that some amount of data can be stored in. And variables in most languages have types, so that means that a integer, for example, can store something that is the size of an integer, and that is different from a character. Um, so a variable stores a specific kind of data, and at the bare minimum, a variable is a basic name associated with a location in memory. Um, so one might say that if an integer variable stores an integer and a character variable stores a character, then what is a pointer? Now pointers could be considered special variables in that they, rather than storing integer characters, store memory addresses. So these memory addresses, well, they could be like integers, or they could, they're just another data type, but the data type is special because they since they are addresses, they give the location of something else. You're storing the location of something else, and typically that location is something that is important to somebody. So you're pointing to the memory location of something else, and typically you're going to point to the memory location of another variable. Though it could just be some other location in memory altogether. Um, so moving on, we have the dereferencing and addressing operators. Now the dereferencing operator, if it's used, if it's used, for example, right here, um, if it's basically says go to the location of this pointer, so look up that address that is in the pointer variable and go retrieve whatever is at that location. Um, because we know that the pointer is an integer pointer, it means that it is a pointer that points to an integer somewhere. Um, and then we also have this addressing operator, and the address operator basically says, look at my standard variable and give me the address of that standard variable. So we would want to take that address typically and hand it to a pointer so that a pointer could store it. But it doesn't exclusively have to be used that way. So if we run this line of code here, we see that the integer variable value and the dereferenced pointer value are the same thing, which was what we'd expect because we assigned those to each other. And then the integer variable address is the same as the pointer variable's value. Again, we would expect that. But remember that a pointer is a variable itself, so it actually has its own address, and we're just showing that in that last line there. So moving on, we have a couple different kinds of memory. In C, you have memory on the stack, and you have memory on the heap. Memory on the stack typically it takes care of itself, so once you allocate it and you're done with it, it'll free itself up. You don't have to worry about it. Memory on the heap, on the other hand, um, is a significant issue because whatever amount you put on the heap, you have to make sure to take off the heap. Now, stack is good for small sizes, but becomes very inefficient and in some cases has a limited capacity. So if you are dealing with large amounts of data or unknown sizes of data, you almost always want to use the heap. And so just make sure that in C you have to free this, and that's really important. More higher level languages typically offer garbage collection in some form or another. Now arrays are a bit more complicated, so here's why. Arrays actually represent basically blocks of data. So they can be on the stack, but they still represent a basic block of data, or it's like a segment of data. So you have one one instance of whatever unit of that array. So in this case, we're using character as a base unit. So one instance followed by another, followed by another. And for example, here we are basically saying create 50 of these blocks, and they are following each other. They're adjacent in memory. So one character is this, the other one's this one, next one's this one, so forth and so on and what have you. So A space 3 space 7, those are 4 adjacent blocks in memory. A pointer can point to this, but a pointer can also, upon assignment, point to something else. Now, you're probably wondering, where does this string live? This string is not being instantiated anywhere, and that means while you can update this one, you cannot update this one. This is because this string right here is this string right here lives in the static compiled basically memory of the application. You cannot write to this. It will cause a segmentation fault. So if you want to store a literal and read it, that's great. If you want to update it, don't do this. Put it in the heap so you can write to it. Or if you know it's a certain size, you can also put it on the stack, but that may come with cost performance change, or like, penalties. So this is very important. A lot of people get kind of hung up on where does this live. This lives in the binary, basically compiled output of the actual application itself. And again, this pointer, it can be reassigned to something else. So we take this pointer, even though it's assigned to this random place. Like I said, pointers can point somewhere besides variables. They can point anywhere, but they may or may not point to something that is useful to a developer or the application itself. So this pointer is actually, we end up reassigning it to this char, right? And then what you can also do is a pointer, again, can point anywhere in memory. So a pointer can be incremented, for example, 5 characters to point 5 characters into this string right here. And if we scroll down, we see that this is exactly what we expect. I know this ran a little bit over, but I hope this maybe explained and cleared up a tiny bit more stuff about pointers for you. And if you want to see more short form content, like and subscribe, comment, and let me know.